In this problem, to do with circles, we've got to try and work out the points of intersection between this straight line and this circle. Now to do that, we have got to substitute the straight line formula into the circle formula. But we cannot substitute that in yet because we've got to rearrange it to have either x equals something or y equals something. So if we rearrange this, it would be much simpler to have x on its own than to have y on its own. So if you put everything else onto the other side, you end up with that. So we can substitute x into the circle equation. If we had done it the other way, imagine if we tried to work out what y was, we'd have had to write down 2y is equal to x take away 8. Y is going to be x divided by 2 take away 8 divided by 2, which is 4. So we could have used this one, and we could replace all the y's with that, but that would have been much trickier to use, so I'm not going to use that one this time. So let's substitute this into this equation. So every time we see an x, we're going to replace it with 2y plus 8. So first of all, 2y plus 8, I'm replacing this x here. Then I'm going to add on y squared. And again, I've come across another x, so I'm going to replace that with 2y plus 8 plus 6y plus 29 equals 0. So we have to simplify this into a quadratic equation. Multiplying out these brackets, square the first term, you multiply these two terms together and then double it, and then you square the last term. Keep the y squared there, multiply out these brackets, negative 24y take away 96, and almost finished, and just finish off with the last terms there, and all of that equals 0. So we've got to collect together the like terms. We've got a 4y squared here and a y squared there, which gives you 5y squared. You've got 32y take away 24y is going to give you 8y, plus the 6y exactly is going to give you what's that, plus 14y. And then lastly, 64 plus the 29 is going to give you 93. And then 93 take away 96 is going to give you negative 3. So there is our quadratic equation. To now find out what the points of contact are, we've got to factorize it. And it's quite easy to factorize this because these are all prime numbers. So the only way of making 5y squared is by having a 5y here and a y there. The tricky bit is to try and work out where the 3 and the 1 is going to go from this bit. If I put a 3 here and a 1 there, when I multiply 5y times y, I get 5y squared. 5y times 3 will give me 15, and we need to get to 14y, so we have to put a plus there, and then we want to take away that 1y. And that's it now factorized. To solve it, we can make this bit 0, and also this bit here 0. So you end up with y is equal to a fifth, and also y is equal to negative 3. So we've got the y coordinates for the points of contact. We've just got to work out the x coordinates. And to do that, we put these values into what we had right up at the top here. So this is our equation of a straight line. We rearranged it. So if we put it into here, we'll be able to work out what the values of x are. So if I put when y is negative 3 into here, we get 3 times negative 3 is negative 6. negative 6 plus 8 is 2. So I can write down that when y is negative 3, x is 2. So our point of contact is 2, negative 3. And for the other one, it's going to be a bit tricky, this one. So again, we're going to replace the y with a fifth. So it's going to be 2 times a fifth, which is 2/5, plus 8 is 8 and 2/5. So again, we'll go down here. So our x value is going to be 8 and 2/5. So our coordinate. And there's your 2 coordinates for your point of contact. Any questions on that at all? There is a class here, but they're being very quiet. Okay, so